everybody. Right now I'm at home meeting my new daughter. You're stuck here in math class. I'm going to be gone for about a week. So I need you guys to continue moving on to new things. What we're going to cover today is not necessarily the next topic that we were going to cover had I still been there, because I wanted to make sure that I choose something for you guys to learn that you can approach without having to ask me any questions, because you won't be able to ask me any questions. So I chose for us to talk today about exponents. Exponents are something that are not, I don't want to say easy, because I know it's not easy for everyone, but it's one of the easier topics, and it's pretty easy to get some help online. And I'm sure that if this is something that you do struggle with, you're probably sitting next to someone who can help you out with this. So I won't be available, not even if you email me, because right now I'm spending my time with the new member of my family. So if you do need some extra help, you're gonna try to look online, you're gonna try and find a friend next to you. And if you're really, really struggling, then when I come back, you and I can have a conversation about how to better understand this topic. But I'm assuming most of you guys have some knowledge of what an exponent is. And if not, that's okay, because we're gonna do a little bit of a review here. So I think it's best to understand where exponents come from. So I'm going to begin by reminding you guys about where multiplication comes from. Multiplication is repeated addition. So if I write something like 2 plus 2 plus 2, we know that I could write this as simply 2 times 3. So we know that if I add a number to itself a certain number of times, then I can just simply multiply that number by the number of times I'm adding it. So if I have 3 2's being added together, then I have the number that's being added multiplied by how many numbers are being added together. We know the same thing holds for exponents, for variables. If I had x plus x plus x plus x, if I have 4 x's being added together, then I could combine all those together and write that as 4 times x. Simply x added to itself 4 times. Exponents do the same thing but for multiplication. A power or exponent is repeated multiplication. So an exponent is trying to deal with the same problem that multiplication deals with. I don't want to have to write out 2 plus 2 plus 2. In fact, let's say that we wanted to add 2 to itself 1,000 times. That means we'd have to write 2 plus 2 plus 2 plus 2 plus 2 1,000 times, when we could just simply write 2 multiplied by 1,000. If I have 2 times 2 times 2 times 2, I want a shorthand for that as well, and the shorthand that we've created is to say that this is the same as 2 raised to the 3rd power. So what I have here is my large 2 as my base, and a small number floating above that, and we call that tiny number an exponent. And you might have noticed I wrote the word power here. I'm going to go over that vocab in a moment, but I want to remind you guys that you also can do the same thing with a variable. X times x times x times x would be x to the power of 4. 4 x's being multiplied together. So that's all an exponent is it's dealing with this idea of repeated multiplication, just like multiplication deals with the problem of repeated addition. So before we go into some example problems, I wanted to talk a little bit about the vocab behind this, because I'm going to be using these terms and I want you to understand what I'm saying. So let's say we get a little closer to this 2 to the 3rd power. So 2 to the power of, so this whole thing is what we call a power. So the power is the entire expression, the number that's being multiplied and how many times it's being multiplied. The number that's being multiplied is what we call the base. That's a good word to keep in mind, because I'm going to say things like what if the base is negative, or what if we raise a base to a negative exponent? So the base is the number being multiplied, so here's x as the base, here's 2 as the base. And the teeny tiny number up there is what we call the exponent. Now, you can't have an exponent if you don't have a base. These two have to come together, which is why a lot of times some people might call a power an exponent. Some people use these words interchangeably, and that's fine, because an exponent and a power more or less mean the same thing. We're talking about a number being multiplied by itself over and over again. So one of the things I'm going to want you guys to do is rewrite an expression using exponents. So let's do a few examples of that. And this is going to be on today's practice assignment. So let's say we wanted to rewrite using exponents. And I've got a few examples I want to do here. So first, let's just start with some numbers being multiplied together. Let's say we had 3 times 3 times 4 times 3 times 3 times 4. So that's a series of numbers being multiplied together, and some of them have been repeated. Multiplication's commutative, which means that I can rearrange these numbers however I like. So I could put all the 3's on the left and all the 4's on the right. Now I can rewrite this expression using exponents. So I already know you guys can plug this into your calculator. That's not what I'm asking you to do. So I'm not looking for one number as my answer. I'm not looking for you to just figure out what 3 times 3 times 3 times 3 times 4 times 4 is. What I want you guys to do is write this with a base of 3 and an exponent of 4 to represent that we're multiplying 3 by itself 4 times. And then I would have 4 to the power of 2, because I'm multiplying 4 just twice. And aside from plugging this into a calculator and getting that one number as our answer, this is as simplified as we can get. I can't multiply 3 by 4 to make 12. They have to be if we want to rewrite an expression using an exponent, we have to have the same number be multiplied together. So that's why I have a power representing the 4 3's being multiplied together, and a second power representing the 2 4's that are being multiplied together. And this is how I'd like you to leave your answer for today. I'm not looking for a number, I'm looking for an expression that's using exponents. We can do the same thing if variables are involved. Let's say we had 3x times 2x times 3x. So first of all, this is all just a bunch of multiplication. Even if I don't put a multiplication dot between the 3 and the x, we know this 3 times x times 2 times x times 3 times x. This is all multiplication. There are 2 3's there, so that's 3 to the power of 2. There's only one 2, so you could call that 2 to the power of 1. So an exponent of 1 just means the number itself. And then x to the power of 3, because there are 3 x's. Now I could rearrange this. We could have had the 2 come after the x. We could have had the x come first. But in math, we typically like all the numbers to come first and the variables to come second. Let's do one more example involving two fractions being multiplied together, because I'm also going to be asking you guys to do that on your assignment today. So for our last example of rewriting using exponents, let's say we have something like 1 over x times w over x times w over x. Sometimes fractions follow different rules than other values, so I want to make sure we know that the rules are the same. We just simply say we've got 2 w's being multiplied in the top, 3 x's being multiplied in the bottom, and there you have it. Simple as that. W to the second power over x to the third power. If you're thinking, well, what about the 1 that was there? Well, if you want to write the 1 there, you can. But we know that it's not entirely necessary to put the 1 there. So that's a review of positive exponents, positive integer exponents. An exponent can be anything at all. It doesn't have to be positive. It could be a negative number. It could be 0. It can even be a fraction. The topic of the very first section of chapter 7 is how to deal with 0 and negative exponents. We're not going to talk about fractional exponents anytime soon, but today we're going to try and figure out what it means to raise something to the power of 0 and what it means to raise something to a negative power. So the title of 7.1, which we're going to cover next, is 0 and negative exponents. So 2 to the third power is 8. Because 2 to the power of 3 is 2 times 2, which is 4, times 2, which would make 8. So what is 2 to the power of negative 3? Most students would guess negative 8. And that's actually not true. 2 to the power of negative 3 is not negative 8. The negative exponent doesn't just simply make the number negative. In fact, 2 to the power of negative 3 is 1 over 8. That's a little weird, so let me try to explain why that is. So how I'm going to explain this is I'm going to run through a series of powers. I'm going to start with what we already know, 2 to the third power, 2 to the second power, and 2 to the first power, and then I'm going to continue dropping the exponent down until we get to 2 to the 0, 2 to the negative first, 2 to the negative second, and 2 to the negative third power. So we don't know what 2 to the 0 power is. We don't know what 2 to the negative third power is. So what we're going to do is we're going to start with what we do know and see if we can find a pattern as we work our way down. So as I just mentioned, 2 to the power of 3 is 8. 2 to the power of 2, that's 2 times 2, would be 4. And 2 to the power of 1 is just 2. And that's when we get to 2 to the power of 0. And, well, what does that even mean, right? 2 multiplied by itself 0 times. That's a little strange. So to understand 2 to the power of 0, let's see if we can find a pattern. Well, what I notice is that every time I drop my exponent by 1, my previous answer gets divided by 2. So when I went from a power of 3 to a power of 2, I went from 8 to 4, which is half of 8. And dividing that by 2, we get to our next answer of 2. Now we're going to assume that the pattern continues as I continue moving down into the negatives, which would mean that I should be able to figure out what 2 to the power of 0 is by simply dividing my last answer by 2. 2 divided by 2 is 1, which means that 2 to the power of 0 is 1. Now I could do the same thing that I just did here with any number, any positive integer. What that means is that anything to the power of 0 is 1. 5 to the power of 0 is 1. A billion to the power of 0 is 1. 17.52764 to the power of 0 is 1. Anything to the power of 0 is 1, which is kind of a nice thing because that's easy to remember. So let's talk about moving into the negatives. Continuing this pattern through, dividing 1 by 2, we get 1 over 2, or 1/2. If I divide 1/2 by 2, I get 1/4. And if I divide 1/4 by 2, I get 1/8. So notice what's going on here. 2 to the third power is 8. Then 2 to the negative third power is 1 over 8. 2 to the second power is 4. 2 to the negative second power is 1 over 4. So what we could say is that negative exponents move the power to they move it across the fraction. So if the power starts in the numerator, then it's going to move down to the denominator. So 2 to the negative third power is the same as 1 over 2 to the positive 3 power. If you're feeling a little confused, that's okay. I'm going to do some examples in just a moment. So what you will also notice is that my answers are not negative. None of the answers here are negative. So let's get out of our heads right now. Negative exponents do not mean that the answer is negative. In fact, the only way the answer would be negative is if the base was a negative number. But a negative exponent actually just moves the value to the bottom of the fraction if it starts in the top of the fraction. So let's say we had 2 to the power of negative 5. So what if we were asked to evaluate 2 to the power of negative 5? Now, we do not need to just continue on this table. So to solve 2 to the negative 5th power, one way to do that would be just keep going on with our pattern here. But we want a much simpler way to go through this. So what I would say is to evaluate a negative exponent, we're going to move the power to the bottom, across the fraction. So if you're thinking, wait, what fraction are you talking about? Remember that I can write any integer as a fraction if I give it a denominator of 1. And so this 2 to the power of negative 5 is going to get moved into the bottom of the fraction. And when we move it to the bottom of the fraction, the exponent is now positive. So, and because there's nothing in the, because the numerator is now empty, I need a placeholder of 1. So what happens there is this negative exponent moved the power across the fraction, and now it's a positive exponent. And so to finish evaluating, I just have to multiply 2 by itself 5 times, and 2 times 2 times 2 times 2 times 2 is 32. Because I'm asking to evaluate this expression, I'd like us to get all the way to that final answer of 1 over 32. Now you might have been thinking, he's saying move it across the fraction bar. Why doesn't he just say move it to the bottom? Well, it's because it depends on where it starts. If the expression starts in the bottom of the fraction, then we move it to the top. So let's say we wanted to evaluate 9 to the power, 1 over 9 to the power of negative 2. Okay, so in the previous example, we started with 2 to the negative 5, and we first turned it into a fraction. Then we say that power moves it across the fraction, and now it's a positive exponent. From there, we just had to evaluate what 2 to the 5th power is. This time around, my expression is starting in the denominator, so I'm going to move it across the fraction bar into the numerator. So I moved it up into the numerator, and now it's 9 to the power of positive 2. We could put a placeholder of 1 down there, but when the 1's in the denominator, it's not necessary to continue writing it. If we have 1 in the numerator, then you have to leave it as 1 over 32. But in this case, we could just simply write this as 9 times 9, or 81. So, a negative exponent moves the power across the fraction, and then the exponent becomes positive. If it starts in the top, it moves across the fraction bar into the bottom, and then don't forget to get rid of that negative. If it starts in the bottom, then it's going to move up to the top, and then it's going to become positive. So again, I'm going to repeat this, and I know I'm repeating this over and over again, but this is a tricky thing for a lot of students. So let me just say it one more time. a negative exponent moves the power across the fraction. A negative exponent moves the power across the fraction, and then after we're done moving it, we ditch the negative and we write it as just simply a positive exponent. All right, so we can actually create a general rule to follow for the things that we've covered today. And I'm almost done. We just need to kind of summarize what we've learned and then maybe do just a couple more examples so you guys are ready for your assignment today. So one thing we could say in general we can say that if we take a number, let's call that number A, and we raise it to the power of 0, this is equal to 1. So I'm putting a box around that because this is how we're going to remember what to do with the power of 0. So when we see this, we think, oh, that's right. Anything, so that's kind of why I'm using the letter A here, anything to the power of 0 is 1. If I raise that base to a negative exponent, so we have A to the power of negative n, then this is going to become 1 over A to the power of positive n. So this reminds us that if we have a negative power, we move it to the bottom. If it starts in the top, if it starts in the bottom, like 1 over negative n, then we move it up to the top, and it becomes a positive exponent. I don't need to write a denominator of 1 if the expression ends in the top of the fraction. If the expression ends in the bottom of the expression of the fraction, I need 1 as a placeholder. So the idea of these general rules, which we'll call properties of exponents, the point of these properties of exponents is that if I ever forget how this works, I can reference this in my notes and I'll say, oh, that's right, negative powers move across the fraction. So let's put these properties to use. So let's evaluate a few different problems here. Let's say we wanted to figure out what 14 to the power of 0 is, 3 to the power of negative 4, and then let's go ahead and do 1 over, let's say 5 to the power of negative 3. Let me just make sure I didn't miss anything there. You know, one thing we haven't talked about is a negative base, so I'll do one more example after that. But let's just start with what we've got here. 14 to the power of 0. Well, anything to the power of 0 is just 1. Boom, that's it. It's just 1. Anything to the power of 0 is 1. Negative 14, 144, 1,000,000,004, anything to the power of 0 is simply just 1. Three to the power of negative 4. So the point of the properties here is to help me remember. So let's say I'm doing my homework. I get to this problem and I'm like, yeah, I have no idea what that means. So then I look at my notes and I find a problem that looks similar. Okay, so I've got a number. I've got a negative power. Okay, I just need to move it to the bottom. Now I made a mistake there. I still have a negative 4 there. That's the bell going off, by the way. So I forgot that once I move it, it's now positive. So if I want to write this as just one number, all I need to do now is figure out what 3 to the power of 4 is. Okay, so that's 3 times 3, which is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the power of 4 is 81. So 3 to the power of negative 4 is 1 over 81. Lastly, this time our power is starting in the bottom. So again, looking over here, I see, okay, if the power starts in the bottom, then I just move it out from underneath the fraction, and it's now a positive exponent. And again, notice that I am getting rid of the negative when I move it up to the numerator. 5 times 5 is 25. 25 times 5 is 125. So on today's assignment, you're going to be rewriting expressions using exponents. You're going to be evaluating negative powers. There's some matching exercises, some fill-in-the-blank exercises. I'm hoping you guys find it to be pretty easy. And again, if you're struggling, there are plenty of videos on YouTube that can explain it in more detail than I've done here. Or maybe you can find a friend who's pretty good at this stuff. So the only thing left is to deal with the negative base. So let me do one last example here, right here. Let's say we had negative 2 to the power of 3. So that's negative 2 times negative 2. That's positive 4, because a negative times negative is positive. So if I multiply that again by negative 2, I'll get negative 8. However, if I did negative 2 to the power of 4, I'm going to have a positive number. Because negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. But then if I take negative 8 and multiply it by another negative 2, I'll get positive 16. So we see here that if it's a negative number raised to an odd power, the answer is negative. If it's a negative number raised to an even power, then the answer is positive. That's all I have for you guys today. Thank you for watching. Get to work.